Hi guys, my name is Ivo and I'm from mytestedasp.net. For the last couple of years I have been working as a CTO, I have been working as a senior software developer, and part-time I have been working as a technical trainer, mainly with the modern C# and JavaScript technologies. In my free time I tend to write a lot of code. I create open source packages mainly for ASP.NET Core. Recently, I decided to start video series about the development of these projects, and I hope you like them. I will be teaching you some interesting techniques I learned during the process, and I hope you get a lot of C# knowledge for free from me. Okay, the what's the project all about? The project is a fluent testing API, which allows you to assert the ASP.NET Core framework quite easily, actually. I have been working on this project for more than 3 years now. It has a lot of code, it has a lot of interesting features, and at times it was quite difficult actually, and I had to read the ASP.NET Core code directly, I had to read the Entity Framework Core code directly, and I had to learn how the whole ASP.NET Core technology works behind the scenes in order to develop this project. During this process I learned a lot of stuff and I decided to start sharing them. I will be teaching tutorials, I will be live streaming code sessions, and whatever you like actually. If you find the project useful or if you like the project at all, you can give it a star, take a look around, contribute, whatever you feel like. The project has 46 packages today and has been downloaded quite a lot of times, which is quite impressive for me. I didn't expect that actually. What I'm going to show you today is an issue I ran into when Microsoft decided to upgrade their server-side technology to version 3.0. Recently I have been uh, patching my libraries to work with version 2.2, and I started updating it for the new .NET Core that is going to be released soon, and realized that Microsoft made a lot of their classes from public to internal, and I have been using these classes and I need them in my project, so I had to find some solution. If we take a look around in the ASP.NET Core project, there's an announcement repository. In the announcement, somewhere here, we can see that breaking change. Unfortunately, a lot of library creators, like me, used these public classes that Microsoft exposed previously and now have to make some workarounds. Here it is. They're making a lot of pub internal types in MVC completely internal. What is a pub internal type? Pub internal type is just a definition of a class which was public, but it was used by the MVC framework internally. For example, the class responsible for the creation of the controllers, the class responsible for invoking your actions, and so on. These classes were public and I was using them because my main focus in my project is to replicate the exact ASP.NET Core behavior in the test as it will be in the web application. So if they have a class that is invoking the action with a specific logic, I use it. If they have a class that is creating controllers with a specific action, I use it. If they're having a class which describes how to execute action filters, I use it. The whole idea was to make the framework the framework behavior exactly the same as the original ASP.NET Core, but that made me use some of their internal classes or classes that were public but in internal namespace or that weren't supposed to be used in a normal web application. Okay, that's cool, and since they decided to do that breaking change, a lot of library creators that were using these classes were quite disappointed in these comments, but I understand Microsoft. I understand that this decision because um, they're constantly changing their internal classes to make the ASP.NET Core technology better. And if they have to think whether they're including a breaking change with every uh, version released, that will be huge difficulty for them. They will have a lot of trouble to follow all the classes uh, in their project, so they decided to make it easier, and that's completely fine. However, I had to find a solution and had to use somehow the internal classes. For example, this class I was using, that's a startup loader class, it was public before. That class has a single static method which is called load methods, and the whole idea behind this class is that it loads, if we go to a simple ASP.NET Core application, it loads this class. If you're familiar with ASP.NET Core, this class will be fine for you. You will know it. You register services here and you register middleware. That's it. So this class was the startup class was the startup loader class was responsible for loading all this logic in the startup class. And since I designed my framework to have a test startup class where you replace services with mocks to make it easy for you, and this test startup class actually describes your mocked services, I had to load the test startup class the same way they load it. And instead of copy pasting the logic behind the loading, which is quite a lot of logic, it will be quite troublesome for me if I copy paste it, because if they change the logic I have to change it in my project too, which is problematic because I use 6 to 10 of their internal classes, and if they change something in one of them I have to find what's changed, why it's not working, and so on. So I decided to use them directly. I decided to use these classes directly in my code, and as you can see I have test application startup loader class. It doesn't matter what exactly we have here. What matters is that in the previous version I could write something like this: var startup methods equal startup loader. I could use the class directly because the class was public, and hit load methods and everything's fine. Since that class is no longer accessible from my project, I have to use reflection and have to use the internal type. Yeah, I know that's not exactly best practices to use internal types from reflection. That's actually awful, if you ask me. But I decided to choose the better option because both options were bad. The first option to the first option to solve that problem is to use reflection, and the second option is to copy paste this code. The lesser of two evils is actually use the internal class directly with reflection, and sometimes such things happen. Sometimes you have no other choice. You may be working with legacy code, and you may be working with third-party package, and you may need to call something internal, you will do it with reflection. Hopefully, uh, hopefully your code will depend only on public classes. That's the best scenario, but sometimes you don't have any other choice. So if I wanted to continue developing my project, I had no other choice but use directly the internal method. Okay, but the code written with reflection is quite ugly. Here it is. I had to hold the assembly by name, this assembly, as Microsoft.asp.core.hosting. Then I have to get the type by name, by its full name, Microsoft.aspcore.aspnetcore.hosting.startuploader. And when I get the type, the class, I have to get the method with these binding flags. The method is called load method, load methods here, with binding flags non-public and static, because the actual method is an internal class, so it's not public, and it's static. Okay, and then I have to co-invoke with a no. The no describes whether the class or the method code is static or whether we have an instance. If we have an instance, I will pass it here, but since it's a static method, I'm passing no. And an array of arguments to pass to the method. That's the iService provider, the type and the string. That's not important currently. And I looked at this code and decided that it's quite ugly. I don't like it. And I tried to find something which is, I guess, less ugly and something that looks a bit better. And I found it. It was interesting. It was an interesting technique that I didn't know before that, and I had like 5 years of experience or more with C#, and it was something new. So I decided to show you how to make this reflection code prettier. I understand that it's not a common scenario to use this technique, because you have to be in a quite strange place where you have to call something that's not private. But I believe you will learn something from this technique. Okay, the end solution is here. So instead of writing down this code, which is, like I said, I don't like it, we can call it like this. Directly, I can call load methods and pass the arguments. There is no invoke, there is no no, there is no magic load method string. It looks quite a normal C# code, and it looks great. It's fine. Okay, but how did I do that? I did that with the help of the dynamic object. Yeah, I know dynamic objects aren't the best practices either, but since Microsoft included dynamic objects in the language, they thought it will be useful and it will have some advantages, and indeed it has. The dynamic object can be used with data that it's not structured. For example, if you have a JSON that doesn't follow any specific schema, one way to parse it is by magic strings. Each property is a magic string and so on. But the other way to do it is by using dynamic objects. And with dynamic objects, the code will look better. Just like my code here looks better. So I decided to use dynamic objects, and I don't have any disadvantages of that. The code with dynamic objects is not less performant, it's not slower, it looks better. Yeah, I don't have IntelliSense or code completion, I don't have it, but I don't have it here too. Yeah, I don't have touch.load methods. I don't have IntelliSense, but I don't have it here too. So actually, I'm not losing anything by using dynamic, and the code looks prettier, so I guess it's a small win, and I'll take it. How did I do that? How did I make the old methods callable by a dynamic type? Well, it turned out, because I didn't know that, it turned out that you can create your own dynamic objects. You can create your own dynamic objects and you can define their behavior. So, after a small research, I found that you can use dynamic objects to access internals of an object. I will link this article below the video in the description. And there are some ready-to-use solutions about this problem. Exposed object, which uses the same technique. There is another solution, and so on. These solutions were too huge, they were having a lot of features, and I only needed to call methods and properties that were internal to make my library work again, so I decided to implement my own version of this. And now I'm going to show you how to do it. But I will show it first like a small separate demo. It will not be part of my project because the code is it's not a lot of code, but still I prefer to write it like a separate project for you to understand better. Okay, so we have the following scenario. We have some class library, cool library, which I have been using for a long time. For example, AutoMapper. AutoMapper is a great library. I believe most of you know it. And you have been using AutoMapper for like 3 years. And you decided to customize something in AutoMapper directly, in the configuration code. Then, for some reason, the author of the library of AutoMapper decides to change one of the classes to be internal and all of its methods. So you have no other choice but use that library with reflection or with the technique I'm going to show you. Okay, let's create a static class. I will replicate the same case I had with the startup loader class. Some cool class and some method I cannot use outside of this assembly. We'll write something like that. Okay, good. If I reference the cool library from my main console project, I won't be able to use this class because it's internal. You should know that if you're a C# developer. So the reflection way first. The reflection way is to call, first I have to get the assembly I need the internal type from. And that's done with assembly using system reflection, load new assembly name, and I have to provide the name of that assembly, which is cool library here. Okay, good. Then I have to find the type I'm looking for, which is some cool class. So to get the type, I have to use the assembly get type and provide the type name. The type name is some cool class. Unfortunately, this returns no. Not because the type is internal. That's not the reason. It's because you need to specify the type by its full name. The full name of the type is the namespace dot the name of the class. So I have to adjust that and make it like this. Then the type is loaded, which is great. Then I need to use to get the method. Remember, I'm still using the reflection. I'm not using anything dynamic yet. Get method, get method, and I have to provide the method name. The method name, I don't remember it. Cool method. It should be in a single form. Okay, and if I try to call it and get it like that, I find it, which is great. But if the method was marked internal, I won't find it. By default, reflection gets only the public members. If I want to get anything that's not public, I have to specify it explicitly. There is a binding flux enum, which allows me to specify what kind of reflection I'm exactly using. I'm using get method reflection for non-public and static classes. I can make it to search for instance and static classes that are not non-public, or search for non-public, public, instance, static, whatever. But since I know the method is non-public and static, I can use only these two flags. That's great. Then if I say method.invoke, I have to provide the object that the method is invoked from. But since this is a static method, I don't have an object, so I'll get a null. If it was an instant method, I would have to provide a class instance. Okay, then new object 0. What's new object 0? New object 0 shows that I want to invoke that method without any parameters, because the method does not have any parameters. And if I run that, I can see 42. Yeah, that's great, that's cool, but it's ugly. If I have some parameters, it gets even uglier. I have to provide them like an array of objects, which is not very cool. Some text. Okay, let's print that to see that it's working. I will also make that return some string, and I'll do it number plus text. Fine. And I want to invoke the method. I want to get the result. I will have to cast it as string, because the reflection doesn't know what kind of type this method is returning, so I have to specify it explicitly. And I can print the result. So I should receive 42, some text, and the result of the method. That's cool, but it's ugly, again. So I will use some sort of dynamic objects to make that work better. Okay, what to do now is I'm going to create a new class. I will call it exposed object, because actually that's what I'm creating here. I'm exposing internal objects. And the C# language allows me to create a custom dynamic type, and allows me to define the behavior of dynamic types. For example, if I make if I make it, for example, 42, you know that the C# language allows me to do dynamic whatever I like, actually. Whatever I like. I can call that method. That method will be resolved runtime, and if it exists and if the method signature is the same, it will be invoked. But since integers does not have whatever I like methods, that's not working. But I can make it work. If I have an exposed object, I can say, okay, let's inherit dynamic object, which is from system dynamic. Dynamic object is a special class that allows me to overwrite default dynamic behavior. One of the coolest thing which you can do with the dynamic object is to make a JavaScript like object. I don't know where you're going to use it in a C# code, but you can do it. You can make an object like dynamic my black hole is new object, and then you can say my black hole dot name era1, for example, my black hole that was name is my tested ASP.NET, and then you can say my black hole dot name. This is not going to work with the default implementation. This is going to throw. This is going to throw exactly like the whatever I like method is throwing here. Object does not contain a definition for name. Yeah, it does not. But if you overwrite the default dynamic behavior, you can create an object that can have the properties attached to it at any given time, which is kind of cool. Again, I'm saying you should not use dynamic unless you find a reason to do so. I already gave you some examples where dynamic is actually quite useful. For example, my case where I need to call internal methods. Another case is when you parse unstructured data. That kind of data will be full of magic strings if you want to parse it, but with the dynamic object you can do it. And you can do it with, I don't know, 200 or 300 lines of code. Okay, so how can I make the whatever I like method work? We can overwrite some of these members. These members try binary operation, which is some binary operation, converting object, creating instance, deleting, get index, get member, invoke, set index, and so on. Try invoke member, this one, is the one that overrides the behavior when I'm invoking a dynamic method. So essentially, when I say invoke whatever I like, I can override the try invoke member and say how exactly the whatever I like method is going to work. So how to do that? Let's do it like this. Public override try invoke member. For now I'm going to return the base invoke member, which is the default implementation. The default implementation throws an error if the method does not exist. So if I say something like this, I want a dynamic object to be this exposed object, and then I want to call whatever I like, and if I hit a breakpoint here, I will see that this logic is invoked, so I can override it and I can write a logic which describes how any dynamic method is going to be invoked. So all of these overridable methods in the dynamic object base class have some sort of binder. The binder is actually a class which gives information what exactly the user is trying to do. For example, I can see that I'm trying to currently call whatever I like method, which is quite cool. I see what is the return type, it's system object. I see who called that method, called it the program class, and so on. So essentially, I'm receiving the binder with information about the dynamic call. I'm receiving the arguments that were called in the dynamic method, for example. Some text. These two arguments will be passed here in this array. And when I set the result variable, which as we can see it's an out variable, I will provide the result from this method. So if I say var result equals this, if I say dynamic result, what I attach here, it will be provided as a result here, and I can make every dynamic member work by just returning true. Returning true or false gives the C# runtime knowledge whether the dynamic invocation was successful. And then if I say result equals my result, I can call that method. I can call whatever I like actually. I can call my tested ASP.NET with something else, for example, true, so on. And if I print all the arguments, and if I call that, I will see that actually it's working. I'm calling whatever I like method, I'm calling my tested method. I have 42 here, I have a bug. So here it is, whatever I like with its parameters. My tested ASP.NET with its parameters. Quite cool. So I can make and I can bend that exposed object to work exactly how I like. And I can overwrite whatever behavior I find suitable to overwrite. For example, try get member is when the user tries to access a property. Try set member is when the user tries to set a value to a property. You have a get index, set index, and other operations. Never mind that. So if I want to make this code here work with the dynamic objects, I can say it like this. Okay, let's have a type, and this type is going to be provided by the constructor. And this is actually the type which I'm trying to access with reflection. The internal type is that. Then the next thing is when I say try invoke member, I will search that member in the type provided here. So essentially I'm going to say something like var method is this dot type dot get method binder dot name, because here is the name of the dynamic method that is called, and I will provide the binding flags using system reflection, the binding flags that I was using here, because that's essentially what I'm trying to accomplish. Okay, if I find the method I may return false or return base try invoke member binder arguments result if method equals no. You don't like. Okay, the idea here is that if somebody tries to call a non-existing method with the expose object, I will let the default dynamic implementation deal with it. But if the method exists, I will invoke it just like I'm invoking it here. So essentially I'm going to say, okay, invoke the method with no, because I currently know it's static. Otherwise I would have to provide an instance. That's something I did here. This exposed object works both with static or instance methods. So I have that logic here. I will give you a link where to find it if you want to examine it. It's in my repository. It's in source, abstractions, the first package. Then it's in utilities. It's not in utilities, it's internal. What's wrong with me? It's in utilities. Am I crazy? Oh yeah, I'm crazy. That's in the development branch currently has 2.2 version where I didn't need that feature. I didn't have to use dynamic objects, so it's not created yet. But in preview version 3.0, which is actually the code that I'm trying to port the library to version to .NET Core 3.0, here we will find it. Abstractions, utilities, exposed object. Here it is. I will link it in the description too. Okay, so let's return to the exposed object, but the simple version. I will say, okay, invoke the method. I know it's static, so here's a nice little no, and these are the arguments. Give me a result from that method and assign it to this result here, so that the result from the internal method is directly passed to the result from the dynamic invocation. And then I'm going to return true. So what I can do now is I can remove that ugly code and I can say, okay, I want some cool quas to be an exposed object by its type. And then I can call the method which I'm trying to access and it's internal, and I can say call cool method, and yeah, I don't have IntelliSense, but I don't have IntelliSense with reflection too, so that doesn't matter actually. And if I have to provide the arguments, that's an int and a text, a string, I will say 42 and something cool. If I run that, I can see that actually the method is invoked. Here it is. These two console write lines wrote down those two parameters, and that looks quite beautiful as code. Yeah, it's dynamic, but it looks like a regular code, and I don't have to write that ugly reflection code. I have to write it once here, but in my other code it's quite okay. I can use the result of the type directly because dynamic objects are casted. So if I know it's a string, I can use string result, console write line result, and here is 42 something cool. So actually I'm calling an internal method from an internal class with kind of a cool technique. Here it is. Of course, since I didn't implement the properties, for example, if I have an internal string name get set, I cannot use that. It's a static one. Yeah. I cannot say some cool class that name equals my tested ASP.NET. I cannot do that because I'm only overriding invoking of methods. If I call this, I will see exposed object does not contain a definition for name. Yeah, I know that, because exposed object actually does not have name. But if I override public override try set member, I can say exactly the same as here. I can say var property equals this dot type dot get property binder dot name. So I got the property. I need these two binding flags, but since I hate copy pasting classes, I will use a read-only variable, a private field. You should never copy code, kids. If you copy code, you should think about whether it's cool and it's not cool, and you should think about how to solve it without copying the code. You have quite a lot of options: refactoring methods, refactoring classes, extracting parameters, fields, whatever. I will make a lecture about refactoring, since when I ported the library to 3.0, I tried to make it work. I didn't care about code quality. There are some ugly codes, for example this one. Here I have the same magic string. I'm loading the same assembly twice. I should cache it. I should extract the string, so on. When I go to refactor the code here, because I only care to make it work, and I'm almost finished and it's working currently, but I have to refactor it to be a little bit prettier, because it has a lot of ugliness currently. So I'm going to make a lecture, a live coding session. I won't explain as much as I'm explaining here. I'm just going to refactor the code and give some tips here and there how to refactor your ugly code. And that's why don't copy code. So, okay, I found the property. If the property is no, somebody is trying to call a property on the exposed object that does not exist. So, if it not exists, I will call the base implementation, which will throw an exception, the default behavior of the dynamic type. Then, what I need to do is to say property. You found it. Set value, the normal reflection stuff. Set value, is there an object? Currently no, it's a static one, so I will give the value and I will return true. So from now on, if I say some cool class dot name, and name is an internal property, and if I run into build errors, where? Try get method flags. I need to provide the flags, otherwise it will try to find the public method, and as we know, public methods don't exist here. So no exception, it's working. And if I see the some cool class, I will see that it's actually non-debuggable. That's because I don't have a direct reference to this. But I can implement the try get member, which will allow me to say console write once some cool class dot name. And as you can see, I'm using the internal type as a normal C# object. The code looks nice, but I'm getting an exception that the definition for name does not exist in exposed object. That's because I override I made the overridden method only for the trySet member, which sets a property, and the tryInvoke member, which invokes a method. I need to override another one, tryGetMember, if I want to have the option to get a property, to access it and read its value. The concept is the same. We have a binder class with information, we have a result from the get access, and that's pretty much it. So what I'm going to do is I'm going to get the property. If the property does not exist, I will call the base tryGetMember with the result, with out. You happy? You happy? Okay, and then I'm going to get the property value, saying property.getValue, and I will provide no because it's static, just like I'm providing no here, and then I will return true. And if I hit, I will see that now I am having an access to the internal property too. So if we don't count the first two lines of code, which there is no way I can do what I'm trying to accomplish here without loading the assembly and getting the type, but after that the code looks quite cool, and I can hide this ugly assembly loading behind the facade, and it will become a lot more easier and the code will be readable. That's the whole idea here. I don't have any other plus except that the code is readable. Somebody might say, isn't dynamic slow? Isn't reflection slow? Yeah, but both ways I have to use it. So I have to decide whether I want to use the internal class or whether I want performance. Since the internal classes I'm using in my library are used only once when the test assembly is loaded, and then all the tests are executed fast, I don't care for one reflection call. That's okay. I don't have a hot path calling this dynamic object. These techniques are the same in the ASP.NET Core framework too. For example, if you try to when you create controllers in your project, ASP.NET Core finds them by reflection. And yeah, the finding is slow, but once ASP.NET Core finds your controllers, it caches them and then it's fast. I'm going to make another lecture about making reflection fast with delegates. The one with making reflection fast with delegates will be more useful than this one. This is just a cool trick, the exposed object and the dynamic object in general, but making reflection fast with delegates will allow you to create a lot of infrastructure code that is fast and it's using reflection and it's using conventions, and you will find it a lot more useful and it will help you abstract your applications. But when I have time to record it, I will upload it as ASAP. Okay, so we did that. We did the dynamic object and I'm using the internal class like it's public. It's actually pretty neat. I like how this trick works because otherwise I have to use ugly code like this one, and now the looks fine. I load the startup loader by this facade of internal types, which loads internal types. This has to be cached. I'm saying that that's not refactored code yet. And then I'm using the startup methods directly. It looks very great. Let me show you another example. See, I don't have a lot of usages of the dynamic objects. I'm using it in 2-3, not 2-3, but I'm using like 10 internal classes from the ASP.NET Core framework, and since they made them internal, this exposed object made it quite easy to fix the issue I was having. For example, let's look at this here. The previous implementation was using some of the pub internal classes. Doesn't matter what is root data, root context, actually, it's not important here. What is important is that I was using one of their pub internal classes to get all the actions in the application. And they decided to make that property internal. So in order for me to continue using it, I had to use reflection, which would make this small, beautiful link code a lot more ugly. And with the trick I just showed you, actually I don't have to do anything at all. I just go exposed, and from there on the actions property is dynamically invoked from the internal property. And the code continues to look great without having to write reflection directly. I made two extension methods on objects and or types to make using exposed object easily. I just say give me the startup folder type and go exposed on it, and from there on all methods that are internal or private are accessible. It's quite cool. I believe that's it for this video. Again guys, if you like the content, hit the like button, thumbs up button, give a star on my repositories, whatever you like. Everything counts and I will be very thankful. You can subscribe to this channel because a lot more videos are going to come. I'm going to show a lot of stuff and a lot of other cool C# techniques. I'm going to show some easier features. For example, when I implement something in the library, I'm going to upload it, and I'm going to give a lot of knowledge, so it may be useful for you if you're a C# developer in your career. So if you like the video, thumbs up, comment. You can follow me on social media. You can follow the mytest@asp.net on social media. You can find it here. You can fork the repo. You can try to implement something to help me if you like. Everything is accepted. I'm also looking for sponsors and backers on Patreon and on Open Collective. If your company is interested, it may become a sponsor and its logo will be shown here. The library is not super famous, but a lot of people use it, as you can see. And you can support me on Patreon if you like the video lectures, if you like the library, whatever you like. Some people already do, so I will be very thankful for any contribution, including the smallest thing: a star on the repo, a like on social media, a share with a friend or colleague if you find the video useful, whatever you like. Thank you very much, and see you next time.